So I'm going to start with the fact that everyone thinks that security is so scary. So what I want to do is a picture with you and everyone being very, very happy about security, okay? Very happy faces, everyone. Are you happy? Awesome. Cool. So I bet no one woke up this morning thinking that you're going to see a human Yoda on the stage, right? There you have it. Surprises. So, hi everyone. My name is Liran. Thank you for having me. It's my first time in Ukraine, actually. You have a beautiful country, and I'm hoping to visit it a bit more in the following days. Today we're going to talk about security, specifically some black clouds and then some silver linings in Node security. Anyone who recognizes what is the reference in the background image is going to get 1 million Ukrainian currency from Leo afterwards. Thank you, Leo. Great. So, as I said, my name is Liran. I'm a developer advocate at Snyk, where we build developer-friendly security tooling for open source projects. So kind of making security fun for open source. As other stuff that I'm also doing are some other projects. So I'm very passionate about building CLIs, so cool stuff like that kind of interacts with your Docker containers, interactive from the command line interface. I wrote a book about Node security a couple of years ago, so Essential Node Security. If you want to get it, talk to me afterwards. It's available online. Also volunteering for OWASP, which is a security project, volunteeringly based. We're doing a lot of stuff there. Involved with the Node Goat project, where we are building a kind of a vulnerable educational platform, security project that you can train yourself and learn some security topics. And finally, I'm also a member of the Node Foundation, so I'm taking part in the security working group in terms of, we're going to talk about it more today, so in terms of things of how do we secure the ecosystem. So if you have any questions about any of these topics or anything else, you can find me on Twitter at Liran_tal. Just ping me and we'll be happy to talk. So today, I want to talk to you about a story, right? It's a journey about open source security in Node. And we're going to start with some kind of horror stories and see kind of bad things that happened with Node. Then we're going to learn about some common vulnerabilities that are kind of very related to Node as the platform, as the runtime. And finally, maybe some optimistic ending to this talk of what are measures and learnings that we can do and we can use as developers to better secure our Node products. So starting off, Node is JavaScript, right? And JavaScript is everywhere. It's, as we just saw with Asim talks, it's used for machine learning, right? We use it in a database like MongoDB. We use it pretty much everywhere. And that means also that, we should be more security-minded about it, because that's not anymore just a tool in the browser like 10 and 15 years ago. And as a testament of that, we are seeing great growth in terms of package managers, right? So NPM being actually the largest open source registry for packages, right? And it's almost encompassing 1 million packages, which is definitely going to break pretty soon. So growth is there. And the thing is, with big repositories, just like NPM, big risks kind of come along as well. How do we tackle them? So one of those is, it's a very lucrative attack vector, right? I mean, that you can just infect one library, say ESLint, or maybe Event Stream, that gets 8 million downloads a week, and you are infecting a lot of developers and users of that. So it is a very problematic space to handle. Second thing is, open source NPM is free for open source projects, so it's an open ecosystem, and we can go ahead and submit whatever we want. So we can submit malware and malicious packages that when you install them, bad things happen. And there's little controls for that right now. And it is difficult to scale that, right? How do you find those packages? There's so many ways that you can create malicious packages. For example, you can create and submit a malicious package into NPM, but the GitHub repository for it not existing, or maybe the minified version, is as an NPM module, while the source code is actually on GitHub. So it's very hard to figure it out. And as we will see today, and we will talk about some malicious modules, none of them were actually discovered in an automatic way. That's another testimony of how hard it is to automate finding and protecting the NPM as a precious repository that everyone uses. So as we are going to talk about malicious modules, I want to talk to you about different types of malicious modules that exist on NPM. One of them is typosquatting attacks. The other one is compromised accounts, so actual maintainers having their accounts compromised, and social engineering vectors that we've kind of probably, I bet some of you have heard about. So anyone who have heard about Rimruff all raises his hand? Great. It's a package that was pushed into NPM at 2015. If we look at the package JSON for it, hopefully you're spotting it, but if not, I'll zoom in, and you can see that it has a really good feature. So when you install it, it has this thing called a pre-install or post-install hook. So basically, that's a script hook that when the npm CLI installs things, it can do some other cool things. One of them is to delete your drive. So like if you have downloaded naughty content, and you want to remove that, after clearing the browser history, you can install Liran. Cool. The next one, anyone have heard about crossenv? Cool, great. So crossenv is a very cool project by Ken Dodds. What it helps you do is manage your environment variables for Node and project like that. It's a cool project. The thing is, if I went to the CLI now and did npm install crossenv, I would actually get a different package from the real one. So this is kind of the typosquatting attacks that happen. So people might be able to, misspell a specific package, or someone might trick them into doing that by like answering an issue on Stack Overflow or GitHub and telling them to install the wrong one. So as you do that, it does some weird things. What does it do? Let's take a look at crossenv as a package. This is how it looks. As you can see, it's called crossenv, which is different from the real crossenv. But interestingly enough, crossenv is bundling the real crossenv. So when you install it, you get the real functionality. Amazing. This is pretty cool. Abstraction for you. But as we just learned from Liran, it also has this pre and post install hook. So when you install that, it runs this package setup.js. What's going on there? Let's take a look. Well, that's a pretty cool file. When you open it, you see that there's some remote host that someone has embedded into that. OK, we're going to read all the process and variables, base64 encode them so we can send them off, do a post request, and basically when you install crossenv, you get a great functionality of environment variables, but at the same time send all of your environment variables API keys in production to someone else. Pretty cool. All right, so as you've seen, this kind of typosquatting attack happens a lot. And if you wanted to go to your friend and tell them, well, let's install CoffeeScript. This is the best library ever for JavaScript, right? I want you to take a second and think, which one of those is the real one? Left or right? No. They are both wrong. They are both malicious packages that were existing on NPM at one point in time until someone found out about it. That's a pretty hard thing, right? So as you can see, I'm sharing a Sneaks vulnerability database. It's free. You can use it. It's open. You can find a lot of stuff. I'm sharing a picture to show you that a lot of malicious packages actually existed at one point in time. I mean, they still get submitted, and we will talk about how the NPM ecosystem kind of tries to fight it. But it's a real problem, and that's like one page out. I had to go through several pages to just show you some of them. So what did we learn about crossenv, right? It had a post-install script, so now you're aware of those, and those kind of can be very scary. The other thing that we learned about is, it calls home and sends this base64 encoded of your environment variables. But the thing that I'm going to ask you is, how did we even find out that this existed in crossenv? Did someone actually, is NPM doing anything special to let us know? Is someone automatically finding them? No. Someone just tweeted about it because he observed some weird thing in the file. There were no proactive measures to find those things and, protect users from finding them. So moving on, ESLint scope. That's a very popular package. It is, as a module, it is very valid. It's part of the ESLint project. But a specific version of it, 3.7.2 specifically, was published as a malicious package. Now, ESLint scope is a pretty popular package. It gets downloaded quite a lot. Those are weekly downloads, 8 million. All right? So the thing is, what it did when you installed it, it took all of your npm or C file, which is you have all of your tokens there for npm, and send them also to a remote attacker, which is great because what do we have in npm or C? Only publish tokens for those of us who maintain packages, right? So the funny thing about this one is also got noticed by someone in the ecosystem, in the community, and he shared that actually it failed, right? He tried to install it and something went wrong. What went wrong exactly is, he noticed it's running this lib build whatever, and he's getting this HTTPS GET request failing up, and it looked kind of malware-ish to him. So he opened the issue, talked about it, and the next thing that we are going to look at is what's going on there, right? So it's doing the same thing. Post-install script that's taking lib build and going to go and take all of your npm-rc tokens. So here's how it looks, but kind of interesting is why did it fail, right? Someone tried to do something. So it failed because they had kind of maybe basic or a gotcha moment with JavaScript and event emitters. So as you can see, it's actually doing, an HTTP request to paste bin. So it's taking all of the malicious script code from online. It doesn't have it inside what it needs to do, and it downloaded it. When it gets everything back, it's going to go and try to evaluate it. So it's going to run JavaScript dynamically from what it got. The only gotcha that it failed is if that's a really big JavaScript, and that's a really big content being transferred. When you're evaluating it on data, that doesn't mean that the entire code got in, right? That's not the end of the event. It's just part of it. So it was stopping in the middle of it. And this is how we found out about it. The thing is, who depends on ESLint scope? Probably no one here heard about this project before. Well, only Bubble ESLint, only ESLint, only Webpack. Who uses one of those? Yes, that's the scary thought, right? All right, so what happened? It was a bit of a mess. It affected a lot of users, obviously. NPM invalidated all tokens, when this accident happened. It meant that it broke a lot of builds that had those NPM tokens, inside them to do stuff. Kind of like an estimated potential of like 4K users, what more may be compromised, maybe not. We don't really know a lot about it. We just can track the download count for that malicious package. And how does something like this even happen, right? That's kind of what I want to get into, because these things can happen. But how does ESLint get a malicious package out, published, doing some bad things? So let's talk about compromised contributors and maintainers. So we're all just people, right? You are all using maybe Webpack, React, TensorFlow, whatever, Node, Express. But these are all people behind them. These are human beings, right? Kind of strangers that you don't really know a lot of their security aspects and what happens there. So what if I told you that 14% at one point in time, not so long ago, were compromised? 14% of NPM modules were compromised. It's a very scary thought. They accounted, those wasn't just some few of those that you didn't hear about. They accounted for 20% of all of NPM monthly downloads. That's a lot of modules, a lot of users that we are affecting. How does it happen? Do you know Express, React? Do you know debug? Do you use React? All of them at one point in time were potentially compromised. So a security researcher actually gained access to all of those to publish packages because he worked with us in the working group. We know that nothing really happened. We have reported that to NPM, but all of those in one point in time happened. And that's kind of how I feel when I hear this, something very popular get compromised. What's going on? So 600 users had their, or maintainers had their password set to 12356. Cool password. It's easy to remember. You can type it in really fast and then publish your package. What can happen? Thousands of them, 1,500, had their password set to their username, which is a bit trickier. Scary JavaScript stuff. And 11% of them, which is a very bad practice that happens generally, had their password reused, being leaked in somewhere else, and then they reuse the password. And we have access to those data breaches, and we can find out those passwords and reuse them again. So this is how a security researcher was able to get access to all of these packages. Some maintainers may not have followed correct practices when protecting their accounts. We're going to talk and get back to it later on today. So for event stream, I'm not going to dwell into the technical details. That's a pretty long story. It's a pretty popular one, probably one of the most sophisticated attacks we've seen, in my opinion, on JavaScript in terms of how it was targeted and how it was employed, and the fact that for like 2 months it went unseen and no one had actually done anything about it. The story is, this is kind of like the last example of malicious packages hitting the registry through a social engineering attack where a malicious, event stream is an OK package, right, existing on the registry for like 8 or 9 years, but it got, unmaintained for a bit. Maybe it was mature enough. No one actively maintained that. Someone jumping in, saying, I want to help. At one point in time, adding a module into the package JSON. At another point in time, making that module do some malicious stuff after, getting added into your package JSON for event stream. And once you install it, you get from that point on the malicious module. So event stream actually shipped something malicious. So if you want to read all about it, there's the blog thing. You can find it. You can see the old postmortem. It's a really interesting story of the timeline of events and how things kind of rolled up. Next thing is dependency management, right? This is a thing that is always happening, whether you're doing Node or JavaScript or basically just anything else with other language ecosystem as well. So things like when you want to use a package in JavaScript, the NPM ecosystem is kind of having so many interconnections between different modules. So one uses the other, and a nested dependency tree looks very convoluted. It looks very big usually. It's not just one package, and it has no indirect dependencies, right? There are many of them that we kind of get. So if you install, Express, you get Express cookies, which gets, debug, and, there's a nested dependency tree that is very hard to kind of reason about. And one of OWASP's top 10 web risk is, of course, this. A lot of data breaches happen because projects are using open source packages or open source projects with just known vulnerabilities and nothing is being done about it. So while you're thinking, that this is your app, you're deploying that to production, in reality, your code is just a very small part of that. But you're taking the risk of, using open source packages from so many other maintainers and developers that something may go wrong. And I'm not sure if you know about it, but you should really track that. And we're going to talk about it as well today. So who watches after all these dependencies? Let's take a look at something that actually happened. Equifax, a very popular story of a data analytics company, American-based, who got data breached, and they have been, familiar for their story. But what really happened there is that they had this use of Java struts, which is a story of, a CVE getting disclosed, and the project itself was vulnerable inside Equifax for something like 2 or 3 months before someone exploited that to actually utilize this security concern. So if you think about it, there was like a 2 or 3 months time where the disclosure for the vulnerability for Java struts was out. No one had done anything about it, like fixing it, upgrading it, taking the server off the internet, anything that you can do about it, just do it. But no one had done it. Someone 2 months after went ahead and hacked them, and this is how they got into the rest of the data. So data breaches really happen because of unpatched vulnerabilities for something that we know about. So these are some black clouds in Node security, right? Let's talk about common vulnerabilities that we have in Node and JavaScript in general. So, not this one. Let's talk about regular expressions. Who likes regular expressions? No one likes regular expressions. You like to write them? Right. Who likes to read regular expressions? Let's start with that. Right? So you just like to write them, but never maintain them afterwards. It's great. Great spirit. All right, so the thing is, they're kind of like this magic unicorn, right? Like when something happens, you feel very uplifted, like it worked, it's amazing. But there's like a really complicated state machine thing and how the operators work and how it affects. And we may use them at some point, but not really understand how things actually happen behind the scenes. So for all of you, those of you who are raised their hand, maybe you can tell me what this regular expression does. It's very simple. Look at it. I do not need TensorFlow to figure that out, Asim. So it's an IP address, obviously. All right, so Once you figure that out, you write it, you ship it to production. Amazing, it works. Except regular expression has some problems, and what I want to do with you is interactively maybe have a session where we can kind of build like a Spotify app to kind of match songs, and we're going to see how things can be very problematic when we try to write them. So here's a starting point. I'm going to move on to some live coding a bit. So if you don't see something, just tell me, but I guess you should see that. So we're going to start from scratch, and we're going to build some regex to match song titles. So you can build something like Spotify, and you can bring that to Ukraine, do the startup stuff. Cool. So we're going to start off with something that starts and ends, and a capturing group, so we can actually take that. And I'm going to start with just maybe matching characters. So anyone want to give me a good song title? So I'm going to default to my Britney Spears. Oops, I did it again. It's a good song. Did it get here to Ukraine? Yes, you know it? Cool. So this matches, but the rest of it doesn't. So I need to do some stuff to my regex, and this is how regular expressions work, right? You try it, sometimes see if it works. So I'm going to match different characters as well, so I can match things like that. But it still doesn't work when I give it more strings, so I need to add something like quantifiers, so I can repeat that stage. So starting to work, that's good. And when I have spaces, I need to add something like a space matching thing. And maybe it does exist, maybe not. So maybe a question mark to kind of say, well, maybe there's a space and maybe there's not a space. It doesn't always have to be a space. Maybe some song titles are one words, like oops. It's a very software engineering kind of song. Oh, it happens to you as well? Cool. So the thing is, I need to repeat this thing, right? This is great, but I need more words. So oops, I did it again. Doesn't work unless I repeat this capturing group. And great. So what do you do after this works? Great, thank you. Ship it to production. It's already there. It works. No, but I know that you are very responsible engineers, so you will do what I do when I do this stuff. I do like this, like really long song titles. It still works. That's great. I love it. Can I ship it now? Right, because we don't also need any test suite. You can just test it manually every time. But what happens when I input something that is bad, that the regex didn't expect? Something like an exclamation mark at the end of it. Now, if there are any backend developers here, because we're a Node conference, and you may not do front-end, I'm going to give you a tip. If you see something red on the screen, that's usually a code in front-end to say that something went bad. OK? Cool. I'm good on UX. So what's going on here? So basically, the way that the algorithms work in terms of evaluating regular expressions, there are different kind of them, right? It's a state machine. There's like non-deterministic way of doing it, a deterministic way of doing it. The JavaScript one specifically that runs on Node as well is a non-deterministic one. It means that it's going to take him maybe an exponential amount of time to figure out the regex, which is what's happening here. So if we open the regex debugger, we can see that it went through something like 800,000 steps to try and evaluate the regex, at which point it stopped, it halted because it knew it couldn't continue, right? So all I'm showing you is a regex that doesn't work on the browser, and the way that the backend, the backtracking mechanism works and why it happens that way is, if you think about it, how does this matching group work, right? As I am going through the regex patterns, I'm trying to match different strings. This one, and this one, and this one, and this is all OK. But the moment that I get to the end of it, it's not going to match the exclamation mark. So what it's going to do, it's going to backtrack just one of them, just one character, the N one, specifically in our case, and then use the other quantifier that it has, the asterisk, for example, to match the exclamation mark. But that doesn't work either because we don't have an exclamation mark in our pattern. So it does this recursively over and over again, and it takes an exponential amount of time to get to a state where it actually matches it. So we're not going to wait for that, of course, so the browser stopped it. But what happens when this is happening for you in, say, in Node? So let's take a look. So I see that you're saying stuff. That's good. It's large enough. So I have my processes down here. I'm running, so you can see like the node process going up. And as I'm evaluating something like the exact same regex that we gave in the browser, and I'm testing it with something like my song, and when it's done, just output done. I'm running it. That's fine. What happens when I'm doing something like now it's going to take far more time, and you will see my Node app using 100% of the CPU, because the one thing I missed to tell you about regexes is that they are CPU bound, and that's why this is a problem for Node projects, right? So we know not to block the event loop in the CPU, and I'm not going to wait for this, of course, to end. But this is a real problem that we have to understand and take into account when we're working with them. So this is known as a regular expression denial of service. And actually, it affected many libraries. Even Node Core itself was at one point in time, not very long ago, 2018 March, it was vulnerable to some a module that had this vulnerability. So as we walk through it, we understand catastrophic backtracking and the way that even small regexes like that, when written badly, could be exploited in a very bad way. So as I'm telling you this, I know you're probably wondering, well, does this really happen? So do you know maybe MS or Moment, or I don't know if you know the top ones, but they are kind of like used as indirect dependencies. So you wouldn't use them directly, but they are used. And you can see the monthly downloads for them and things that happened. And like I said before, this is a real problem that is happening in the ecosystem for different modules. So what are my best practices around regular expressions? Thank you so much. You're just getting the $1 million. So, but before that, there's a way that you can actually use regular expressions in a proper software engineering world. You read a paper on how attack works, how regular expressions work, and once you are responsible enough, you are certified to use them. I provide certified stickers for regular expression developers. So talk to me afterwards if you read it, and I'll give you one. And indeed, the best, if you didn't do that, because I know no one is going to read that paper, so please do not use regular expressions. My next one is my favorite best practice. Okay, point taken. Great. So I know that sometimes, joking aside, you do really need to use them. So first of all, what you maybe want to do is go ahead and try some other library like Validator, which is a way to validate strings, right? So if you need to validate or like match regular expressions like base64, an IP address, telephone number, whatever, this probably has it. It's better to use Validator instead of writing your own, just because you may make more mistakes, and some mistakes in terms of DDoS attack actually existed for Validator, but they will probably find it and fix it better as a general community instead of just yourself writing something and probably not knowing about it after something happened. The other way that you can use is safe regex. It's kind of, it may give some false positive and not find DDoS problems, but if you want to test if your regular expression is valid or not, you can try and use it just like as a one-off, and it will tell you like true, false, whether it's good or not. There are other ways to find about regular expressions if you have something like more of a convoluted code base. But of course, if you don't care about any of this, you can give this to your project manager, and ship to production. Value fast. Okay, cool. So I want to show you some other vulnerability. So I have this app. Cool. Let's start it. So I have this Goof app, which is an open source thing at a project that you can just go to like sneak/goof and take it and learn from it as well. And it's vulnerable, and I want to show you some stuff about it. So things like, if you go to the About page, you see maybe like some static files getting served, but also it has this secretive kind of endpoint. like about new, which is going to give you like a template-based output. So, for example, this doesn't relies on like it's not a single-page application, so there's no React or Angular around it. It's just templating, right? Like handlebars and EJS, etc. So it's also easy to reason about in terms of as we educate about security, and it has this great parameter where you give it a device, and if it's like a desktop, it's going to do it smaller. If it's a mobile, it's going to do it bigger. This is where my front-end skills kind of end. We're at a Node conference, so I'm OK with that. And I'm going to try and maybe exploit that a little bit. So maybe I'm going to try and run maybe something like a quote, single quote, so I can maybe try to escape whatever is happening there, because I know it's a templating thing, so something gets evaluated dynamically in some way. That doesn't work, which is bad, but I can try something else. I can try doing something like representing the device parameter as an array, actually, like with brackets. And this is where we get to interesting security vulnerabilities in general, like HTTP parameter pollution. So what happens if you give a web server just device, right? But then you give it device equals something, and then device equals another thing. What does it do? It takes the first one, the second one. It's an array, it's a string. How does it treat it? So with Node, in JavaScript, things are kind of loosely typed. So the way that they evaluate it is a bit different from other languages. And if we just use an array, it actually still works as well. Nothing breaks, except if I'm giving it a quote, I'm now seeing that something is interesting happening down the road. What's interesting is I'm seeing that it's an unexpected string, and then I know that something really interesting is happening. And my app is using Dust.js, so that's like the vulnerable package. And if I look at something like the way that this about new actually works, see it? I have this if condition in my code, which, of course, a lot of dynamically templates need to have this kind of like literal, so they can do kind of things like that. And it has this if condition, device equals desktop, right? And that gets evaluated. So if I did something like good. So far, so good. But what happens if I now know that the Dust library is actually vulnerable to this attack, because we've just seen that we're able to alter the way that data gets interpreted? So I know that this is what I have in my code, and now I can think about, well, maybe I can escape it in a way that will allow me to basically maybe execute stuff, right? Because I can do something like this. And the statement just gets, the expression actually just gets evaluated, right? Because I'm now trying to do something like a meta operation over strings, but to evaluate what console log does, it actually needs to run it. So I've now created a way to run things while giving it input. So if I had done something like, we need to escape it. So something like this. And device is desktop. So things are OK. And as we go through it, maybe it escaped those as well. So maybe we're trying to give it an array, and we see the exact same error. So nothing really fancy here, just to show you how that works. But then I can go ahead and give it something like that. And now I have actually called my server side to execute something, right? So this is a vulnerability in Dust, in a node-based templating engine that allows people to remotely execute code. So I have an exploit example that I can show you later that actually I can go ahead and do require, process, and spawn a shell script to do something, whatever I want. Cool. Like not cool, but cool. So, so far, we talked about vulnerabilities, right? And we talked about some horror stories. Let's talk about how we are improving the ecosystem and what we are doing there. So one of those things is, first of all, the NPM ecosystem, go too fast, has an ability now to countermeasure things like typo squatting attacks. So at this point in time, right now, there are existing two modules called JSON stream. They are different, but they do exist. One is uppercase, one is lowercase. The thing is, we can't really remove any of them because the ecosystem relies about them a lot. So if we remove something, we rename it, we are breaking a lot of really, users going to be very angry about us. But except for that, we are able to combat typo squatting attacks. So if I have this React Native library, which I know is popular and people are NPM installing it, and I wanted to go ahead and attack it in terms of creating a malicious module, I can try creating React Native without the dash, except now NPM detects that, because what it does is it compares the original name, like React Native, without the punctuation and similar letters, with what you give it, and see if there's a match or not. So it's going to deny if you're going to publish something like this. It's going to deny if you're going to publish something like that as well. So what you can do, if you really wanted, you can use scoping, right? In general, I like that a lot because it also implies source instead of just someone installing something, where that is coming from. So there's like nice semantics around it beyond what it gives you, the whole entire namespace capabilities. Another thing that happened in the NPM ecosystem to combat a lot of the malicious stuff going on is they started doing notifications. So if you are publishing packages, every time you push something, you would get an email about it, right? Because think about stuff like happened with ESLint scope, right? Someone published a malicious package, and then the maintainer could have said, well, if I got this email, but I know I didn't publish anything, so what's going on, right? So that's kind of like more awareness into understanding when things happen. So we have those as well, so that's nice. The really thing about it, like the really interesting part is that I want you to enable two-factor authentication, right? That exists. So if you're module authors, if you're maintainers, please enable that for whatever platform you use. It is so important because of what we've seen in terms of compromised accounts. If you don't want your package to be compromised, you should do it. It exists like 2 years already through the NPM CLI. It exists through the website if you want to do it. I have this tweet that was sent by Adam Baldwin he's a security person from NPM. Just a couple of months ago, he said that my emphasis is, only 7% of maintainers have enabled 2FA, right? That's the thing that we have to deal with, to educate, and work with the developer community to work with more practical practices in terms of security, like enabling 2FA so their accounts won't be easily compromised, like we've seen. The other thing is, and I'm really happy about it because I know that developers wanna be more responsible for a lot of things in their stack. One of them is their application security and dependencies. So I had published a report about a couple of months ago on the state of open source security. It's very detailed and interesting if you want to go through that. One of those aspects was to ask about maintainers and developers several questions about their security postures to understand how people are working in terms of adopting practices and what's their state of it. So as you can see, when we asked, who do you think is responsible for security, most developers thought, they are responsible. And this is like the optimistic part where I think this is really true. I think we want to own, being responsible for security. We just need maybe some tools to help us make this, very easy and right. So one thing that you have out of the box and easily to use is NPM. When you install something, you will get like how many dependencies. You will understand like the ability to fix it as well. So that's one of them. NPM it just exists right there. The other thing is Sneak. If you have any questions about it, I can talk more. But I just want to talk about some differences between it. So it's easy to install, just authenticate to connect your repositories and stuff like that. And Sneak test kind of works the same way, except some of the differences that exist are things like, we are going to catch things are going to work the same in terms of if you ran NPM audit or Sneak test, so you're going to get the same kind of report. Of course, a bit different, but the same details. Things that we have at Sneak that are kind of important as well is streamlining that with your developer workflow, right? So once you connect it to your GitHub repository, at that point, we can go and say, well, now we have your build failing because someone introduced a package that has vulnerabilities, or maybe we just detected that it got malicious or something, right? So we have the ability to break the build if something happens, and this is just right there, streamlined with your workflow. You don't really need to do anything, except just use that. The other thing that I really like about Snyk is, it is very actionable. So we don't just want to say, something is failing because of a vulnerability. What we will actually do once you connected, things like your GitLab, your GitHub repositories, if there is a vulnerability existing in one package, for example, Mongoose was vulnerable at some point, what we will do is go ahead, create a pull request to your repository, offering to update the small minor version, a smaller minor version that we can update that is possible. Do not break your build with major upgrades, if possible. We will update your log file, so it's also locked in a good way. And the only thing that you care about is just making sure that test runs well, nothing breaks, and merge it. There we go, right? Remediating vulnerabilities in a very actionable way. So there's a lot more about Snyk. I'm happy to tell you about this more. Let's talk about the Node security working group. It's a very big part of things that I do with Node. So just as an awareness so that you know that it actually exists, right? It's a group that group of friends of us, we meet monthly. It's open broadcasted, so if you want to follow up, if you want to get involved, you can easily do it. It is transparently managed through an issue queue on the Node repository namespace. And some of the stuff that we are tasked with, right, is there's two parts there, right? One of them is a visible part to the community, which is working through the issue queue in terms of creating policies, creating security practices, reviewing some Node security features that you may have heard about, like integrity checks and stuff like that are going to go into Node maybe soon. And we are working with the Node core people to do all of those stuff and all of those reviews. So that's a very interesting part. The other kind of behind the scenes, very invisible part that happens and honestly takes a lot of the work from everyone here on the security working group is actually we are the incident response for vulnerabilities that happen in Node, right? So in Node, and I will expand it in the NPM ecosystem, right? So it's also Node core as well as NPM ecosystem. So if you found a vulnerability in Express or Mongoose like we saw before, you can report it to us through something that a program that we have in HackerOne, which is where a lot of security researchers go to in terms of reporting vulnerabilities in a very responsible way. Meaning what we will do is there's a security disclosure so that when you report something to us, it is private. No one hears about it at the first time. It's not like a 0-day that someone just releases a security vulnerability in a very important and dependent upon module. So we will work with you to triage it, investigate the problems, contact with the maintainers, which is, by the way, very oftentimes a very hard part for security researchers because open source is so hard. And at the end of the day, we're maintaining a public vulnerability database. So all of those vulnerabilities actually get consumed by maybe other vendors. So maybe if NPM audit is telling you, or even Snyk, right? It tells you, I have a vulnerability in Mongoose. There's a good chance that we received this vulnerability in a security working group. And when Snyk and NPM, read the database that we maintain, they got this advisory. So again, a lot of work there. I'm happy to talk to you more about it. Some of the modules that we triaged, you can see there's an uninitialized buffer for 2 million downloads a month in base64 URL. And again, maybe you're not using that directly. That's probably an indirect dependency for many modules that you're using. How many of you use React SVG? Another popular library that had an issue that we have triaged, as well with Serve, as well with Protobuf. So we are doing a lot of work. If you want to get involved, if you're interested, I'm happy to share more. So let's recap, and I'll let you go to lunch. So what we learned today, a lot about malicious modules, how maintainers can be compromised, and why is it important to enable 2FA. Some common vulnerabilities, like beware of regular expressions. If you write them, be responsible for it. I showed you remote code execution in templating, so definitely don't do evil. But in our case, it's not even us who did it, right? It's the Dust library and the way that it works. And in an optimistic kind of ending, we have a lot of tools and practices in the NPM ecosystem that we've just reviewed, and we can leverage them to help us build a better and secure ecosystem. So thank you very much. I had a pleasure being here. You can ping me Twitter again and talk to me, or I'm just hanging out with a goofy hat. So thank you.
Thank you so much, Liran.
Sure.
Guys, maybe you will have a question. Yep.
nice talk. Thank you. Not a question, but one remark. You mentioned one package. It's called, just a moment, validator. So in fact, there's two packages with there are two packages with similar name,
Yes.
and we have validator and we have validator.js.
Yes,
and
right.
the second one is
Malicious.
also has security problems.
It is malicious. It's
Yes.
right. Yeah. So it is already. Oh, so you wanna finish, or was the comment?
No, I just wanted to comment
Right. So it's the same.
This.
Correct. So it's the same thing that we talked about with malicious packages. You're completely correct. Validator.js is actually, I think it is the malicious version.
Yes.
And if you use if you install it right now, so what npm does when it finds that a malicious has gone, as a package has gone malicious, it will keep the name itself. It will not remove it, but it replaces it with like it says you will see in a README page like security placeholder. So it's basically just like an empty package that does nothing, just so that it doesn't break it, because maybe someone used it and we don't want to break their build. So it's going to be like a null package, and you're correct. That's indeed the case.
Yes. And just, I don't know, maybe just a little update. I would recommend using a Joy validator for validating packages and incoming data parameters, and maybe Express validator if you use Express framework. This works perfectly. And as for regular Express DOS issue that was mentioned during this presentation, Mongoose also has this problem. At least it had this problem in previous packages. So, as far as I know, you basically guys have to know that about buffer attack in Mongoose. Yes, that's right. Thank you.
Sure. Yes. Yes, until you do it. So buffer is an important aspect in terms of Node. There's some issues there in terms of the way that it used to work is start with uninitialized memory. So when you used it, and when Mongoose used it, I think that's kind of the PR problem that we saw before. It was using it to initialize memory with already written data. So basically, there's a better way to create buffers. The different API. The thing is, we can't just break that API. We kind of tried for a bit in Node, but we realized it's going to break a lot of stuff. If you're interested about that, we have a small initiative to kind of try and find all the places, see what's the use case for it, try to get everyone to migrate to the new one, to like the buffer from, and not the constructor way of doing it with new buffer. So you're welcome to be involved as well. So, or anyone else, of course. Yes.
Thank you for the speech. I have a question. Do you think that limiting concurrent requests is part of security also? And how would you choose the limit boundary for that?
So yes, I do think it's an important security concern, but not just security. It's performance-wise, and you want to have a healthy environment. There are different ways of doing it within the Node ecosystem in terms of there's NPM packages for doing that, like Express brute force or something like that you can apply, or a flexible rate limit or something like that. I wouldn't necessarily, like if you can use something else, like front it with like a reverse proxy or something a bit smarter to do it, I would use that and not let that kind of smell my code with Node, because like as an application in terms of generally architecture, I do not want to add that into every maybe microservice that I have or something like that. I mean, again, it's doable. It's possible there are modules for that. I would try to maybe put like an API gateway that will be responsible for that and leverage that in terms of doing it. So yes.
So thank you, guys. If you will have more questions, you can ask Liran in the tech corner after lunch, or before,
or during,
or during the lunch.
You know, Yoda also eats.
Yeah, or during the lunch. So please, thank you, and.